I'm Shawki Ali. I am a power systems consultant at Siemens, and I had the pleasure to work with ASEA, Charge Up Europe, and EIT Urban Mobility regarding on the question. And the main question that we were asking ourselves was, how much does it cost? How much does it cost to invest in the European electric grids when we talk about electromobility? And it's a simple answer. It's 25 billion euros. Just to put it in relation to other values expected by the EU, it's 1/3 of the Europe's estimated 60 billion euro annual electricity grid modernization equipment. But we didn't stop at this. We broke this down further. We broke it down to clusters, we broke it down to countries, and we broke it down to cities. We have investigated 64 urban centers in Europe, seeing how much grid investments are required until 2030. But we didn't even stop at that. We asked ourselves, what are the solutions? What are the possible solutions? And one of the possible solutions that you already have in mind is EV load management. And now that I have your attention in the room, I would like to start with the executive summary. Executive summary, what was this project about? We started by clustering Europe into 4 zones, starting with the Nordics, 5 countries, Central Europe, 8 countries, Eastern Europe, 11 countries, and South of Europe with 6 countries. Do I have here? We have the Nordics with 8 countries, Central Europe, Eastern Europe, and South of Europe. And we have concluded that for all urban centers for all urban centers within the same cluster, they have the same behavior. They act similarly when with the impact of electrogrids, with the impact of electric vehicles on the grids. And that's why out of these urban clusters, we chose 6 representative urban centers or 6 representative cities. These are Stockholm, Kiel, Munich, Rome, Barcelona, and Krakow. For the Nordics, we chose Stockholm. For Central Europe, we chose 2 cities because of the sheer number of urban centers in Central Europe. For South of Europe, we chose 2 cities, Barcelona and Rome. And for the East of Europe, we chose Krakow. And you can see here on the right-hand side the ramp-up factors. As for the passenger cars, we have a relatively similar ramp-up factor across all of Europe. But this factor differs for light-duty vehicles. For light-duty vehicles in Eastern Europe, we expect a ramp-up that goes up to around 10 times the current share of light-duty vehicles in Eastern Europe. And when we move further to see, okay, what's the impact of this ramp-up on the grids? We see here on the left-hand side the required grid reinforcements in 2030 across the 4 clusters, across the different voltage levels, and we see the savings that the load management can have, and the required grid reinforcements with load management. Just to understand this graph. So if you don't have load management, this will be the same bar chart or the same representation throughout the presentation. If you look at the whole bar, that are the required grid reinforcements without load management. And if you look only at the yellow part, that are the required grid reinforcements with load management. Jumping on to the grid investments, or to see how much does this grid reinforcements mean in money, in euros, we see that the highest investments are expected in Central Europe with around 16 billion euros. And I would say that is logic, that's expected, because Central Europe has the highest number of urban centers, has the highest population. This is followed by Eastern Europe, Nordics, and South of Europe. How did we conclude all of this? How did we come to all of these results? We did that by creating an EU grid model. The idea of an EU grid model is to say we don't have a homogeneous grid in Europe. We don't have a single grid in Europe. Every city is different. Every urban center is different bases where they are starting from, and different development in the next 5 to 10 years. So we started by creating the grid parameters. The grid parameters are derived per city based on publicly available data. And this is a very important point. The whole grid model, the whole information or data flowing into the grid model are publicly available data. And this means that by following our methodology, you can land on the same results. And also this means that anyone here can follow the methodology and can land on these results, can find the same results. The second build-up block would be the BEF ramp up. In this block, we deduce the BEF ramp up and the peak load per cluster based on a detailed analysis of representative cities. So for our 6 representative cities, the one that I've shown before, we made a detailed analysis of the BEF, how it's developing, what are the charging profiles, what are the driving profiles of the people or of the electric vehicles in these cities, and then we prognosed these results to the remaining 64 urban centers. Once we have found the grid parameters and the BEF ramp up, we did our grid analysis. In the grid analysis, we analyzed the future asset loading and determined the necessary grid reinforcements per city and asset type. And that's what you have seen a couple of slides back regarding all of the cities. We have deduced, okay, for each voltage level, what are the required grid reinforcements. And of course, last step would be the grid investments. We have calculated the required grid investments per city and asset type. Without digging deep into the methodology, and also with the short time that I have today, I will jump directly to the findings. Here is an overview of the findings. The first finding says, grid digitalization is the prerequisite for EV load management. I believe this is a very straightforward, and I believe no two people in this room can argue with that. EV load management reduces reinforcement needs significantly, but physical grid upgrades remain unavoidable. And this is another finding that is crucial. Load management is not a silver bullet with which you can avoid all of the grid reinforcements. It is a helping factor. It is a technology that can reduce the costs, that can reduce the required grid reinforcements, but it does not reduce it down to zero. And this is an important point. The third finding, every European urban center requires grid reinforcements by 2030. So no matter the ramp up, no matter the grid situation, no matter how it looks like today, no matter how it looks like in 5 years, with the BEF ramp up, every European center requires grid reinforcements. Number 4, Central Europe faces the highest absolute investment burden by 2030, and we have seen that already on the first slide. We can dig deeper into that, but as I said, it's simply because of the number of urban centers within Central Europe. Eastern Europe has the least time to act, and this was a surprising finding in our study. Eastern Europe, even though that the BEF share currently is somehow, I would say, modest in comparison to the rest of Europe, but the BEF ramp up in the next few years is one of the strongest. The grids aren't prepared for this, and this creates a compound problem for Eastern Europe. Number 6, the low voltage grid is where BEF integration hits hardest. Now, when we talk about grids, we need to differentiate between the different voltage levels. And we have seen that as for the low voltage grid, it is the most affected by the BEF ramp up. Number 7, EV load management can increase LV grid hosting capacity by up to 20% by 2030. And this is also another realization, another finding out of the study, that with LV management, we can increase the LV grid hosting capacity by up to 20%. Now let's dig further into finding number 1. Grid digitalization is the prerequisite for activating EV load management. Without grid visibility, the cost saving from load management cannot be captured. We see here on the left-hand side the costs. We did 3 cost calculations. First of all, the grid digitalization, how much money do we need to spend to digitalize other grids? Load management, the costs for load management, and the cost saving with load management. And you can see without load management, Central Europe will have to pay the full amount of grid reinforcements, also around here. And you can see here on the right hand side the cost saving with load management. So with applying load management, we can save from 40 to around 55% of the grid reinforcement costs, depending on the cluster, depending on the country, and depending, of course, on the city. I will move on to the second or to the 6th finding directly. The low voltage grid is the primary stress point of BEF integration and the highest leverage target for both conventional reinforcement and smart charging solutions. We see here on the left hand side the share of each voltage level to the total grid investments. The highest share across Europe, across the band, is the low voltage grid. So we should start with the low voltage grids. This is the bottleneck for BEF integration. And this graph on the right hand side stresses on this information further, stresses on this info further. We can see that across all clusters, across the voltage levels. LV grid always have the highest grid reinforcements, always requires the highest grid reinforcements until 2030. And this brings me to the end of my presentation. Thank you very much for the time and for your attention. And I'll give it up to your moderator. I think we'll take it from here.
First of all, thank you for setting the basis. I think that was a good introduction into the topic already, so I'll keep mine as short as possible. I'm Moritz Bohland, Head of Energy at Reev, Munich-based energy and charging platform, and I have the pleasure to moderate this panel today on the topic that is named From Energy Crisis to Energy Flexibility, Unlocking the Role of EV Charging Europe's Smarter Grid. And before I jump into the question, I just want to flag one number that I find really astonishing. So last year in Germany alone, curtailment raised up to 1.8 terawatt hours. This is a really incredible number. So this amount would have been sufficient to power 1 million electric vehicles for an entire year. And I think this really sets the basis and shows us where we stand in the transition, because we were quite good in the last years in ramping up renewables, but not so good in making sure that demand also follows supply patterns, which in the new electricity system that we now have is a necessity. And I think we as EV charging industry have the really powerful lever to close this gap. Not completely maybe, but partially, and I think this is also a bit our responsibility. But we cannot do it alone, so we need the proper regulatory environment, we need real incentives for our consumers to participate, and ultimately also their trust, because we need their flexibility. We're just aggregating, we're using it, we don't own it. So this is just to set the basis for what's to come, and I think we have a really strong panel here from, you mentioned it, from industry, NGO, European Commission, and also the academic perspective. And with that, I want to introduce our panelists. It's a bit difficult with a mic and my cue cards. So starting next to me, Geert Kuik, Electricity and Grids Manager at Transport and Environment. Then Claire Levavasseur, Policy Officer for Renewables and Energy System Integration of DG Energy. Then we have Hallgeir Horne, Senior Manager Charging Infrastructure of Circle K. And lastly, Martina Barjaková, Behavioral Scientist at Open Evidence. So welcome to all of you, and let's get started. So the first question is one that it will be the same for all of you, and basically I think it's rather two questions. So given the current energy crisis, what can the EU gain by fully unlocking the flexibility of EV charging? And secondly, what are the conditions that need to be met for consumers to trust, adopt, and ultimately also benefit from flexible charging services? So you can freely choose upon the order, whoever wants to start.
Give it to me.
All right, I think it's already been kind of mentioned where it can contribute, right? By having more flexibility on the demand side, of course, we can match more the consumption with the production that is becoming ever more sort of unregulable, that is just producing whenever the sun is shining or the wind is blowing. So introducing demand that is not flexible at this point in time is not a great idea, because it will halt sort of the possibility of us to decarbonizing the grid. And then in addition, sort of from my perspective, leaning a bit into the flexibility services is a key enabler for the infrastructure required for the green transition, especially in mobility. Because if we can't put batteries in our toolbox, we can't really build the chargers that we plan for. And if we can't do that, we can't really play our part in the transition. So it's key.
Do you also have like a perspective when it comes to the what we need for consumers to actively engage? So how do we leverage this?
I think there are other panelists that might be better at this, but from our perspective, we want to provide an offering to our customers where they are not really impacted by the situation in the power grid. So the congestion, the intermittent power production, we want to provide them a product which is high power charging whenever they need it, and we have to solve the complexity of actually making that happen in the constraints that we have with today's power grid and power system.
Who wants to go next?
Thank you. Thanks for the invitation. So yeah, I'm not gonna repeat the figures you already know, but yeah, indeed today we really think that it's time to accelerate electrification of transport, but that the story doesn't end here, and that it's just the beginning. We know that flexibility needs are expected to double by 2030 and even more by 2040, and that's where we see the huge potential for smart and bidirectional charging. It can bring benefits to both the system, energy system, as we just saw, but also to customers. So it's really a win-win solution. But its deployment is still facing some challenges. So we do think that there are both ways to address these challenges. First, it's making the best use of the current regulation. And second, it's to also make it more interoperable. Just to recall a bit what the Commission has done in that regard. So we already have a solid framework thanks to the Renewable Energy Directive, the EPBD, the Data Act, the Electricity Regulation, and the Electricity Directive. That basically enables more renewables in the system, more flexibility, data sharing, and more electrification. Then last year we published a guidance on anticipatory investments, but also guidelines for network charges to reduce system costs. In December 2025, we cpublished the grids package, alongside guidance on timely and efficient grid connections. So we do think that it's a key component of this framework, especially thanks to the acceleration of permitting with deadlines for recharging point integrations. So basically, it's also about grid planning and alleviating congestion and preventing them in the future. So this quiz package is a key component. So now, what is expected in the coming month? So we'll have the electrification action plan published on 15 July. The aim is really to unlock the acceleration of electrification in general, but also for transport, of course, and also to enable to create enabling conditions also for smart and bidirectional charging. We'll also launch the regulatory sandboxes for V2G. So as I mentioned, the first component is how to make the best use of the current regulation. And this regulatory sandboxes should address this. And last but not least, the revision of the grid codes that should be shared with member states this summer. Then we'll have a public consultation to have your say on the internet. The drafts should be even shared before the summer. And after integrating all the comments, publication is expected after that. So this network code, of course, are essential to provide technical requirements to better connect EVs to the grid, and to have one common set of rules for OEMs. And last one, network code on demand response, which is also expected to be adopted soon. So we had an ECBC in March. This summer there will be another ECBC and the submission of the network code proposal. So this is also advancing. We do think that all these aspects are also replying to your questions from the Commission side.
Okay, thanks for sharing. That was very extensive. Now I think we know what is to come next.
Yeah, thank you. So I think at CNE, well, we couldn't agree more with smart charging is obviously the basis. It's a no-brainer. It provides great benefits, and without it, anything, so it really cuts down on system needs and system investments. But we've looked at, mostly at EV drivers in private charging, and there we think that vehicle to grid is really one of the areas where we could, sort of leverage and go beyond the sort of the basic savings and significant savings we get from private charging. So vehicle to grid is really one of those areas where we believe further progress can be made, and the benefits from using EVs as batteries on wheels is really very significant. We published a study on this. I think it sort of aligns with some of the numbers mentioned in the Siemens presentation. By 2040, 22 billion euros of annual savings for the overall electricity system just from using V2G. We can deploy more solar, so integrate more solar thanks to V2G, because you have all those EVs able to absorb that excess solar at midday and then feeding it back in the evening. And we believe that this sort of leads to kind of a virtuous cycle, whereby you lower electricity costs because the investments in the grids will be lower, that will be reflected in the bill. EV charging will become cheaper, and then and so on and so on. So I think V2G we think is also a part of the solution that we want to leverage. And apart from sort of the macro impact on the system, we also see that there is a tangible benefits for individual EV drivers, essentially offsetting or largely offsetting the charging costs for individual drivers that are able to make available their EV battery for this bidirectional charging. I'm very happy, Sudan, we're in Brussels, the Commission is present, so I'm very happy to hear one of my points was on grid codes. Grid code adoption is essential, so very happy to hear that we can look forward to good news this summer and maybe on the demand response soon after. I also saw the leaked version in Politico of the network charges. There's lots of interesting things in there. I know you cannot comment probably, but this whole idea of making sure that when you inject back into the grid, that there is not extra charges levied again on top of that. That is also absolutely crucial for this business case of V2G. And then last but not least, I think we recently went to the Netherlands, where the grid congestion issue and the low voltage level distribution network is really at a sort of a breaking point. There's no more new grid connections happening. And we look at projects like We Drive Solar in Utrecht that really brought together a whole ecosystem of OEM, Renault, but then also aggregators, the DSO, and so on, really bringing all those stakeholders together to really provide a concrete solution to the grid congestion issue. And I think this is absolutely an interesting example, and we'd like to see that maybe spread across Europe in several field trials, sandboxes or whatever you call it, but this needs to be, those examples need to be sort of replicated elsewhere to really seeing is believing. Once you see it in operation, I think DSOs will also be more open to consider non-fossil flexibility solutions and alternatives to grid upgrades, poles and wire solutions. So this is something that we would look forward to advocating in the future as well. And I'll hand it over to the colleague there.
Thanks a lot. So I guess I'm the one here who's going to address the second part of the question, who looks at the consumers. But before that, maybe if you allow me to do a little parenthesis on basically why is there a behavioral scientist on this panel? Why do we need behavioral science? Well, basically because here we're talking about engaging consumers. Without the consumers, none of this is going to work, right? And we are talking about consumer decisions, consumer choices, consumer behaviors, and this is exactly what is being studied by the field of behavioral science. So basically, what behavioral science can help us with are three main things. One thing is understanding the consumers, and this is the basis of everything. So if we want to change people's behaviors, if we want them to take certain decisions, adopt certain behaviors, certain technologies, we first need to understand why they're not doing this currently, right? So this is something behavioral science can help us with, as it is a field that draws on insights from psychology, cognitive science, economics, and many others that really help us understand the human mind, how the human mind works, and how people behave in certain ways, how they take decisions. So we really need to first understand why people are behaving in the ways that they're behaving. And once we have this understanding, then we can move forward and we can design solutions that are based on this understanding. So once we have this, what we call it, behavioral diagnosis of the problem, so we know why people are not maybe engaging with flexible charging services, then we can develop solutions that will help them engage with them more. And we can go even further than this. We can test effectiveness of these solutions. So behavioral science uses scientific methods borrowed from medicine. So we call them randomized controlled trials. So we do experiments with consumers where we really test effectiveness of the solutions that we design. Because at the end of the day, people are different, contexts are different, and everything matters for human behavior. So you really need to test rigorously, scientifically, your solutions so that you can find the one that really works for your consumers. So this is just a brief parenthesis on why behavioral science is important even for this. And now back to the question, so how can we engage the consumers? So in behavioral science, we often use theoretical frameworks to understand which are all the factors that matter. And one of the most used ones is called the COM-B. And it tells us, each of these letters from the acronym basically tells us one group of factors that need to be in place so that a certain behavior, such as engagement with flexible charging services, can happen. So COM-B, the C stands for capability. So the consumers need to be able to engage with flexible charging services. And what I mean by this is mostly they need to be, first of all, aware. I'm sure that there are many consumers who have no idea what flexible charging services are. And so first of all, they need to be aware and they need to have the right knowledge. So they need to know how this works and they need to really understand. And I'm sure I've seen some research, there are many misperceptions for now among consumers about what flexible charging is, how it works, what it can do for them, and maybe they see many risks that are not real, but they see them. So we need to address this. We need to provide them with a good understanding of what this is. So that's the capability. Then the second thing is, that's opportunity. So actually they need to be able to engage with this. So they need to have the time, the resources, whether this is in terms of money, this can be in terms of like mental resources, cognitive resources. So again, they need to understand what they're doing. And basically it needs to be easy for them to do. Because if things are complex, people just say, nah, I don't want to do this, right? But if we make it easy for them to engage, then they may be more willing to engage. And finally, we have the M, which is motivation. Obviously, people need to be motivated somehow to engage with this. So we need to make sure that they see the benefits of these flexible charging services, and then we increase the likelihood of them engaging with this. So I guess I'll stop there.
Yeah, let me just continue right here, because that would have been my first question. Can you share some like best practices on how to do it? I think this would not only be interesting for me, like is it about how do we frame it properly? Is it design choices? Is it, how do we choose like the monetary compensation? Can you dig a bit deeper? Like can you share like what you found in the empirical evidence?
Let's try. I think it's a bit of everything, and I always keep repeating that we first need to understand what the problem is. So we really need the behavioral diagnosis, because there might be many reasons why people are not engaging. It could be the monetary incentives, but it could just be lack of awareness or lack of knowledge, or it could be these misperceptions that I was telling you about. So first of all, we would need, I think, more evidence. I mean, this is quite a new field, so my own research is more on tariffs, on time of use tariffs, dynamic tariffs, and so on, not so much on charging. But I had a look, and there are some papers out there in behavioral science on flexible charging, but not so many. So I think, first of all, we need a better understanding of the causes why people are not adopting these services. But from what I saw, I think a lot is really about the misperceptions. So I saw that, for example, for the the V2G. I saw that many consumers are afraid about their batteries, that this is gonna, destroy the battery and it's not gonna be good for them. So if we have misperceptions like these, we just need to address them. And this can be as simple as a communication campaign, but we really need to make people understand how this works and what it gives them. Surely it can be incentives as well, so absolutely it's also about the design of incentives. And one thing related to that is also risks and uncertainty. So this is, I know it from research on flexibility in general and also on tariffs, where with dynamic tariffs people can save money on their bills, but they can also lose money, right? And so they are very afraid. There is this thing in behavioral science called loss aversion, where we give more weight to the losses rather than gains. So if you have the same identical amount of loss or gain, you're going to be more afraid of the loss than you're going to be happy about the gain, right? So we tend to focus on the negative side, if you want. So if there is a risk, if there is this uncertainty that I'm going to lose money by doing this, then people are going to be scared. So if we can give them some guarantees, maybe at least initially, that look, if you adopt this, you're not going to lose, but you can only win. This could really help them overcome this fear. Also, with these services, people are somehow giving up their control, right? At least to an extent. And this is also something that comes out in the literature as a potential barrier. They don't really like the idea of losing control completely. So if we give them assurance that somehow they can override the settings, they can take their control back when they need it, and also giving them the assurance that when they need the car, it's going to be ready for them, right? So it's not all in the hands of someone else, but in their hands as well. I think this could also help them a lot.
Yeah, I can basically confirm all those points from our practical experiences with setting up a dynamic tariff and using the flexibility, and it's true, and we keep iterating. Yeah, it's not trivial. I would continue with you, Hallgeir, for the more DC charging side. What I heard is that battery co-location is a thing and that it helps, of course, when grid limitation is there. Do you feel that the regulatory environment fosters this? And would you wish for something more in that direction, or are you actually content with the solution? And how do you employ it?
I think we can start with a bit of context from our side in Circle K, is that we are already operating a fleet of, depending a bit on how you count, between 20 and 30 co-located batteries, indicating that in some markets the regulatory landscape kind of allows us to use it as a tool for deploying fast charging. So I guess part of my answer to this question is that it varies a lot between country and country within the EU, whether or not the regulatory landscape allows us to use co-located BESS as a tool to deploy charging infrastructure. And I think that's sort of on an EU level. It's a bit of work to be done on harmonizing sort of the regulations within the member states, because what we see today is that we come to a Swedish DSO and we're met with a lot of solutions and opportunities for what we can do when we install a battery, and then we go to the DSO in the Netherlands, sort of, yes, they are allowing us to install the battery, but they're not really playing ball with us in the sense that they are just giving us 50 kilowatts to work with, and that's far, far, far from enough for us to deploy in an installation of 10 charge points each. That should each be able to deliver 400 kilowatts to the customer, right? So we need that more countries do a bit more like Sweden, and what I mean by that is that they need to lean into flexible or dynamic grid connections as part of what the DSO is sort of forced to look into as an alternative to grid investments. So what we see in the Nordics much more than the Central Europe is that we are given power from the grid that is conditional, in the sense that they might give us a portion of the power or all of the power on the condition that if something happens in the power grid, they'll remove it. But that will allow us to install batteries that can then sort of close that gap to the times where the power grid is not accessible to us. And we know, and the grid operator knows, that the probability of them actually having to cut us off is fairly low and for short durations, so it won't really impact our customers. So if we get sort of pushed to the DSOs that they have to look into this solution, it will largely enable co-location of batteries. And then if we go down to a bit lower level in terms of regulation and actually being able to install co-located batteries, there are also differences there when talking about grid codes. A big issue with that is that the grid codes between member states are nuanced a bit different and interpreted a bit different, so that if we have a procedure and a way to go of installing a battery in Sweden, it doesn't necessarily mean that we can have the same documentation and the same equipment installed in Denmark without meeting a pushback from the DSO. And that makes it, of course, very difficult for us as a pan-European charge point operator to deploy at a high pace, that we can't really make scalable solutions that has more one-size-fits-all. So that's an issue. And then it's also a bit whether or not we can install batteries on the same metering point. It's some DSO has regulations requiring you to split them into two different metering points, and then it's no longer co-located. It's a battery independent from our installation, so the whole purpose is lost. So there's a lot of these activities that I see needed from a regulatory perspective in harmonizing what's happening in each member state and with each DSO. And then if we lift it to another regulatory level in terms of dynamic limits and seeing flexibility as an alternative to the grid. I can also mention that I've been working for the regulator in Norway, so I've been close to a lot of these questions kind of from the other side. And I know that we were not that good at incentivizing the DSOs to use flexibility instead of copper in ground. They get more opportunities to generate more income if they have more infrastructure to operate. So basically what they're doing, if they allow a lot of flexibility in their grid, is reducing their own opportunity to earn money. So this is something that really needs to be worked on. I know that it's coming, and I know there's a general push in both the EU, but also in selected member states on changing a bit this framework for income. But that's really something that needs to be done. And also what was mentioned is the upfront planning, because if they haven't included flexibility in their 10-year plans, they will never be able to do it when it comes down to it, because they have to lean on whatever was decided 10 years ago, more or less. So unless they're forced to think of flexibility at an early stage, they really won't incorporate that into their planning, and that will block them essentially from really utilizing that. Because for us, co-located BESS, the dream scenario is that we get dynamic limits where we today get rejection basically for connecting to the power grids, and we install batteries so that we can deploy at the pace that we want, not the pace that is dictated by the power grid.
Yeah, thanks for sharing. I think one of the problems is that many DSOs and TSOs are not, or rather on the DSO side, are not super aware of what's happening in their grid, and they are super cautious. And in doubt, they just give you very low limits to make sure nothing's happening, and instead of creating some flexibility. But
I agree. So we also need to force them to build more insights. But if there's been any time in humanity where insights is sort of accessible with AI and cheap sensors, it's not.
It should be now.
That's cool.
Yeah. Thank you. Geert, maybe jumping to you, because you mentioned the T&E study. that also highlights that weakening CO2 standards undermines V2G potential of EVs in future. And the question would be how sensitive this is to behavioral assumptions that you had. So are you assuming that all EVs are V2G compliant, and also assuming that users are then actively using this flexibility?
So yeah, a couple of years ago we did indeed this batteries on wheels study showing the huge potential. Now looking at sort of the current political discussions in Brussels around CO2 standards, we felt the need to sort of review that study, and that was published on Monday, to sort of say like, okay, what if there are dramatically less or fewer EVs? What if there's in 2040 instead of 140 million, we only have 90 million EVs? What is the impact on sort of the V2G potential and on the broader power grid? And then what we see is we see a lot less additional solar getting deployed if you get weakened CO2 standards. So there's a whole range of impacts in terms of additional peaker plants. You will have more curtailment, and so this is something that we really would like to avoid. And this worst case scenario that we had imagined in our study also showed that is actually exceeded sort of expectations in a way. It's even in the Parliament, the Salini report on CO2 standards even goes beyond our worst case scenario. So our worst case scenario, we thought we'd get some pushback on like, really how bad can it get? Well, it turns out it can get quite bad. And so this worst case scenario, we're looking really at maybe a realistic option. So for us, it's absolutely essential that if you're talking about consumers, they need to be capable. Well, first of all, they need to have the EVs, and so that's sort of a basic point. It's kind of I know it's a friendly audience here, but yeah, that's just the basic. Without the EVs on the market, we will not be able to engage in smart charging or into vehicle to grid. Then, I mean, when it comes to sort of the consumer, I think the consumer is quite, maybe indeed they need to have it cannot be too complex, they need to be motivated. I think one of the key issues that they also understand what is being sold as a smart ready or a V2G ready EV. I think this is also something where more work could happen to sort of develop either a label or sort of mandate it in the long term to make sure that every EV in the longer term that gets sold is V2G ready, so that the consumer doesn't have to figure out the EV works with this charger or with this, so that this is sort of sorted out for the consumer, and that we can maximize the potential, and that we can have that they are capable when they buy an EV to engage simply into the V2G ecosystem and really benefit from the hundreds of euros and the near zero charging that is available or possible via V2G. So this is something that we think we can motivate consumers to do, but we need to make it simple and easy to access. And we think sort of more action on sort of making sure that EVs are V2G ready is one avenue to pursue that.
But should it be the market, or should it be some form of mandate regulation?
Well, we think that, I mean, we already see a lot of OEMs engaging in this, and this is sort of a great, there's a great diversity of experiences, of projects, of pilot projects. I think this is how the ecosystem grows. This is absolutely essential, but we think it's a stepping stone to sort of standardizing this in the longer term. We think 2032, that's sort of a couple of years away, and the OEMs can get ready for that. And so we think this is something that can be rolled out over time, maybe first with a label, but later on this can be mandated and just become a standard for all EVs that are entered into the market, to make sure that they are interoperable. And we also believe that it should be the EV that should be able to do V2G, so that you have an onboard charger, which makes it easy to you get out of the whole conundrum of which charger works with which EV. So this is something that we're quite convinced that this will help to scale this market and scale this product.
Yeah, for sure. Maybe looking at the time, one last question from my side to you, Claire. Something that is super important for us, because as an industry, we always need access to battery data in the end, because otherwise smart charging is super difficult, because we cannot find out what the current state of charge is, and then optimization into the blue is a bit tricky. So the question would be, because Article 20A paragraph 3 of the RED would actually provide us with this access, but we see from members that there are challenges in the member states to actually getting access to this data. Is there something planned to help member states in enforcing this and implementing this? Maybe you can share a bit of information here.
So yeah, indeed, the Article 28 has already turned into force 3 years ago now. So member states now have to transpose the Renewable Energy Directive. So on Article 28, I think like indeed at least 4 member states have transposed it yet. What we did in the Commission to ensure harmonization, because indeed this is in the directive, which means that member states have to transpose it, contrary to a regulation. And indeed the aim is not to fragment the market, but really to make it implemented in a harmonized way across Europe. So for that we issued 2 guidance documents. And the last one, published in July last year, was a bit the outcome of a dialogue with stakeholders that we held a few months before, and basically really strives to further specify which are the data points behind the RED parameters, namely state of charge, state of health, battery capacity, paraset point, and location. Because these data points are not always standardized. So this guidance really is really helping member states to know which concrete data points need to be shared by OEMs, what real time means for each of these data points, depending on 3 use cases that we identify: when the vehicle is moving, when the vehicle is being charged, when the vehicle is stopped but not plugged in, just to avoid sharing in real time when it's not necessary. And also we specified in this guidance what do we mean by exchanging in real time. So basically we said that it should be done over the air with existing integration points such as backend server of the OEMs, and when the vehicle is being charged, also with any communication interface. So we have released this content of this guidance in different places, because indeed now the aim is that member states use it in order to implement this in the right way. So we have had exchanges with member states. We have explained the content of this guidance in the motor vehicle working group, in the concerted action of Renewables 2 times. And we also have launched an online tool, not only for 28, but for the whole RED, for member states, so that they can ask directly their questions there. Everybody can see the replies. Yeah, so we have done a lot, and I think now it's on the way.
We're glad to hear that, I guess. I would open the floor, for questions there in the back.
What about people when they are being, let's say, when they are being the targets of information campaigns designed to scare them about this technology, about electric vehicles, about new energy products in their homes and things like that? Whether it's like a real active targeted campaign, or just when they hear something that's wrong, either from a friend, from the paper, from a politician, on social media, whatever. Do you have any suggestions for how to respond to that and how to engage people and push back against the, let's say, manufactured fears that are frankly quite prevalent out there?
That's a tough question, but thanks for that. Yeah, I guess using the right messengers could be a way. So definitely responding to these fears or to these misleading information. And yeah, I would say using the right messengers to get the messages across. So you really need to find someone who people trust and try to get across your messages maybe through them. And this, I guess this varies across different groups of consumers. So some people may trust their families, their friends. Some of them will trust maybe NGOs or like some independent bodies that will tell them the information. So I guess there is a lot of heterogeneity in terms of who they trust, but I would try using the trusted sources of information to try to correct the misperceptions. But yeah, it's a really tough thing to do because they have the first mover advantage. So oftentimes what you hear first, you'll just stick with it. So this is a very, very hard thing to do, actually, to debunk myths. You need to try to be quick as well and maybe somehow foresee what the misinformation could be and try to first spread the right information. I hope that answered your question.
Sure, Gabriele.
Thank you. Actually, my question is also to Martina. I think I think behavioral science is fascinating in and of its own, and I think it's even more fascinating to have you on the panel and to bring these two, worlds of policy, but also behavioral science together. Because I completely agree with you. I have no academic background in it, but I'm a very passionate person on this topic. So I think it's great to bring this insights into policy making specifically. So my question is to you: how do you think that the findings of behavioral science or insights from behavioral science could and should be used in policy making? Because I think policy making is very often, we look at economic factors, it's very pragmatic, sort of fact-based, but we all know that people who actually have to internalize those policies and live by them are anything but factual and, pragmatic. So how do you think that policymakers could, look at the work that you do and the insights that you gather and sort of have in the process of the policy making and sort of integrate it so that the policies from the beginning are made to work rather than just based on, economic pragmatic factors?
Thanks a lot for the question. So I definitely think as a behavioral scientist that behavioral science should be used in policymaking. And the good news is it is. It is increasingly more and more used. So I work at Open Evidence, and we're basically a small consulting firm, and we most of the time work with different DGs of the European Commission or different European institutions who want the behavioral insights. So there is more and more awareness about this, even among policymakers, and they really want to look at the consumer side and they want to understand. So this is a good thing. And in terms of how it should be used, actually behavioral science can be used across the whole policy cycle. So ideally, you would have behavioral scientists involved from the beginning, because behavioral science can really help you understand the needs of the consumers, how they currently behave, where they're at, and basically it can give you, it can help you even evaluate different policy options. Oftentimes you may find even that the right solution is not behavioral. Okay, so the problem might be behavioral. You may look at it from the behavioral angle and then still conclude that, well, you just need to give people, incentives, or you need to lower the taxes, or I don't know, you need to do something that is not a behavioral solution, but still the behavioral diagnosis of the problem can help you. And then obviously the place where the insights are being used the most is trying to develop solutions. So how do we communicate certain things, or how do we, how can we develop the behavioral solutions? But it can be used across the whole policy cycle. So whenever you feel like you need to understand the consumers more and you need to do something based on evidence, then behavioral science can help.
So we have time for one last question.
Please.
Thank you. Moritz from DKV Mobility. This question is inspired by a chat I had over a coffee with a colleague from Easy. It's not probably about behavioral science. Thank you. It's about use case and differentiation. So if we look at smart grid and the integration of e-mobility, we have on the one hand the charging parks that you mentioned, Hallgeir, with like 4 kilowatt or 4 megawatt maximum charge and the battery, etc. And then we have AC charging parks. We have parking garages, etc. Those are vastly different use cases and vastly different applications. And the question is, so I see a head shaking already from the expert, and I want to ask, where's this differentiation? Do we have this modeled somewhere? Do we have to look at these different use cases, or is it just we look at low voltage grid, medium voltage grid, high voltage grid, and that's it? It's more for the open panel.
I mean, the toolbox is sort of just nuance differences of sort of doing the same thing, right? So I understand that it's the complexity level is like you have many more nodes in a scheme that is using individual cars charging as part of a big virtual power plant, and working with these is different than what we're dealing with, which is, yeah, it's in a utility scale, it's a small node, but it's still a much bigger node than an individual EV. But the means are, or the outcome and what they deliver to the grid is still somewhat the same, right? You just need many more of them to work with. And the regulation is a bit different because you can't really interact with the asset directly in the same way that you would with us. I don't know if this is the level of the question you're asking, or?
The question I'm really asking that is, if you look at the DC charge park, the goal is everybody gets charged as quickly as possible if it's on the road, etc. If you look at a charging garage at home, people can charge overnight.
Yeah.
And then the goals are very different for the charging optimization.
Yeah.
And I think that plays a big role in this, how you design this, because you don't want to wait at the DC charger. That's what I'm saying. So is this differentiation happening?
I don't know if that's a differentiation happening sort of from Siemens when they're looking at it, but from my perspective, I'm trying to make, if the grid operator is looking at it, it would look the same. I'm trying to, from the metering point, create a scheme where what I'm drawing from the grid is perfectly adapted to what they need me to do with the co-located batteries. And that's a bit what they're trying to do with V2G as well. They're essentially, they have a demand that can be spread a bit out over time, given the fact that it's a battery on wheels. So they're then adjusting what's seen at the metering point in accordance to what's needed from the grid. So it's same thing, fundamentally different sort of how it looks point for point, but from the grid operator, it should be looking fairly similar. It's about controlling a battery capacity that is bundled together to have impact on the grid. So I think it's similar. What I actually have sort of an extension of this question in terms of we're talking a lot about V2G, and you're also mentioning that complexity is an issue for changing behavior, and V2G is fairly complex compared to standard smart charging. And how much do you actually need V2G compared to just having charging happening at the right time? What's the additional benefit? Have any of you looked into that in terms of, can we solve the issue with just smart charging, or do we need V2G?
I think we need to keep it short a bit, but I mean, just briefly, I mean, I also, like, back then we also did some internal calculation on how much you can gain with smart charging, how much you can gain with V2G. I think smart charging needs to be the first step. It's easier, it doesn't really involve the battery, it's just less complex, and it's complex enough from my perspective. So I would always say, like, this is the first step that we need to take, and then we take the next one. But of course there is more to gain on the V2G side, but maybe
Well, I think what the modeling shows is that you also get a different sort of generation mix. Like you're able to integrate more solar, you're able to reduce curtailment. So your generation mix looks different. Maybe on you also are able to reduce grid investment. So I understand it builds on the smart charging benefits, but it goes beyond that. And I think particularly if you break it down per cities or even per districts within cities, I think resolving grid congestion, like really local, zooming in a bit, really at the local level, it can really offer a lot of benefits in terms of avoiding grid upgrades, avoiding additional transformers and so on. So I think it is an additional benefit on top of what you already get from the smart charging. Yeah.
Yeah, I fully agree, and I would love to continue this discussion because I think it's also worthwhile, it's fruitful. But looking at the time, I would hand over to Luuk van Kuik, Director Strategy and Innovation from Last Mile Solution, for some concluding remarks. The floor is yours.
Hi everyone. I know everybody is longing for the escape room or the drinks, right? But so I'll try to keep it brief. For those I haven't met yet, my name is Luuk van Kuik. I'm Director Strategy and Innovation at Last Mile Solutions. And my world is basically smart energy management and payments. And accidentally, that's also where grid flexibility meets, right? At that intersection. We're Europe's largest e-mobility white label platform provider. And over the past decade, I think we have been putting real life use cases out there, not in slide decks, but on the street on smart charging. So I think next to a short summary of what's being told here, I also want to give you some real examples and some real behaviors where we talked about, and also some real results, for example, from WeDrive Solar, which we cooperate with. But first of all, I don't know if I beat AI in summarizing this meeting, but I will do my best. What I took from this panel discussion is first of all, 2040 I heard 22 billion due to V2G introduction. But with a caveat, only when there's enough EVs on the road, and we do a smart push from labeling to standards. Second, for CPOs, flexibility services are in the end, either if you're DC or AC, because that's also what we see in our CPO partners. Flexibility is indeed key for a sound and surviving business model. It's hard to not use that and to still be alive in this market. But I also hear that flex is needed for effective use at DSO and TSO level. And I'm talking not only at regulation and planning, but also in the attitude of DSO and TSO players. Then third, from the European Commission, I think there's been a lot done, I hear, a lot of frameworks, guidance on battery data, revision of grid codes, demand response, all to support flex in the end, in the long run. And maybe to end with the consumer, I learned a new term, so that's always great. So I hope everybody still remembers it, but just to remind you all, it's capability, opportunity and motivation. In the end, making it effortless and showing real benefits to the end user, right? And I honestly hoped that we were past range anxiety, but now we hear that there is battery anxiety at the end. So I hope we can overcome that quickly. So those are the key takeaways I saw. Next to that, I think it would be what I really want to share with you is the proof is in the pudding, right? As we say. So it's not about we can do a lot of research and we can do a lot of assumptions, but in the end, getting in touch with the EV driver in reality, interacting with them on flex services, on load management, on EV driving itself is where you really get the feedback. So let me share some of these with you, what we've done in the past. So in 2014, that's 12 years back, we launched an integrated charge point controller. We built hardware back in the days, now we totally software. That was at Schiphol area where the first Teslas were there fully driving. There were over 60 of them, and it was pure load management. That was quite simple back in the days. It didn't affect the driver. They always had a full battery to drive onwards. If we move a couple of milestones to 2021, together with our alliance, we introduced the world's largest public steered electricity pricing project where we did, and still currently active, over 15,000 charge points being price steered at power levels. That's congestion at the regional level where we're now active. Also there, the consumer is partially informed, but can override. And that's already active for a lot of time, and it gives 10 megawatts of flexibility at this moment, at peak moments. Then in 2023, we introduced an advanced mission-critical load balancing system, including battery, solar, other grid constraints for one of our largest transportation companies. You know them from the yellow vans. Also there, this was multi-site. Also there, in the end, the drivers, the fleet managers were informed. They always have an override. And if you keep them informed, keep them aware, they will cooperate, because in the end they see the benefit. And maybe the most exciting one, and Geert, you already mentioned it, last year we contributed to Europe's first V2G car sharing ecosystem with WeDrive Solo, Renault, the City of Utrecht and MyWheels, which is really an interesting one because until already today it's expanded to Eindhoven and other cities in the Netherlands, so it's a multi-regional congestion easing solution. And you notice the pattern, so every year you see it moves from single site, multi-site, single region, multi-region. So every couple of years it sizes up. But the fun thing is with the V2G example is EVs aren't just consumers, right? They're actually also energy providers, and crucially even more, they're energy carriers. So they can move energy from where it's abundant to where it's scarce. And to give that a bit of an illustration, so in Utrecht, the first 5 months last years, there were 50 cars on the road. From those 50 cars, there was a 70,000 kilowatt hour discharge in the first couple of months. That was roughly 140 V2G hours. Today, they're upping to 500 EVs and have now a flex potential to solve the grid of 2 megawatts. By the end of the year, this will be 5 megawatts. Now the interesting thing, and Geert also mentioned it, the City of Utrecht is wrestling with a 25 megawatt shortfall of energy. So at the moment in Holland, there's in the province of Utrecht a complete lockdown on any new grid extension and any new grid connection. So even if you want to have solar panels or whatsoever, those things don't work at the moment. So imagine when these things start to scale. If we go from 5 megawatts to 20, if you move up the ladder in the number of EVs, there's a real solution out there that already can be applied today, right? And this is still a closed user group V2G example. Picture this. It's an employee driving from home to work with an EV, charges throughout the day during solar peak. At the moment, end of the day, he drives back with a surplus in his car, comes home, peak is highest at net congestion, he plugs in his car and gives back the energy, and therefore really relieving net congestion in the area. That's already now happening in the Netherlands on really small scale, because now the first pilots and products are out there. But this is not charging anymore. This is transporting energy, right? And I think that's where flexibility truly begins. But I also have to be honest, we are not there yet, right? Europe's market is fragmented in players, in behavior and in regulation. But the political view has changed, and is changing, as you heard today. Like a couple of years back, the EV was the perceived problem child of the grid. Now it's seen as the solution, right? And I think that's something where we have to keep in mind, and where we also as an industry should lead, and not wait to become regulated, or become regulated with regulations, because I really believe in regulations, but they should fit the industry and they should fit for purpose, right? And it should be future robust. And I think that was done in the early days already, when, for example, the first protocol of OCPP was born. That was done 20 years ago. Already the vision was there for a fully interconnected, data-driven ecosystem to large-scale electrified transportation based on renewable energies. We were at the table back then, and we really like to be at the table right now to drive this forward. But to get there, I see 3 challenges, and I think a couple of them were announced already today. So first, there's the grid alignment. So I heard Hallgeir and Geert also talk about grid codes. They need to be future robust, and I know there's a lot being done right now, and I hope they really become future robust. and nuanced enough so that it can really help to move us forward. And maybe the interesting one is payments and transactions, right? So if you look at our processing rails in our industry, it was meant for buying energy, not for selling it back. So imagine you're moving now, we have dynamic tariffs for 1 hour. That moves now already to 15-minute intervals. Not only positive, but also negative transactions. So with Redrive Solar in the case, we have positive and negative transactions in our system. But this is all closed user group. But then you can also think of, hey, VAT-wise, suddenly one transaction becomes 2, because you have a different VAT system. How do you handle that? And then we didn't even talk about roaming, because this is all a closed user group, right? So how do we make this interoperable with each other, that it really can be applied cross-border? Because the transportation of energy instead of charging is the new mindset I think we should all have. And I don't have all the answers, right? But we do have a decade of real use cases and an ambition to really drive this forward. So yeah, really curious what you see as one of the most critical challenges to get this out there and hit the targets which are mentioned today. So let's talk it over at drinks or in the escape room, or catch me at Power to Drive next month. I'm more than happy to have a chat. And at Last Mile Solution, we're keen to drive this forward. So thank you.